All right, good morning, class. Good morning,
Good morning, Professor Doyle.
Today we're going to be going over number 33 in the text. For this problem, it says a 350 kilogram flywheel hoisting up an engine has a radius gyration of 600 millimeters. If the power is cut off when the angular velocity is equal to 100 RPM, we want to figure out how much time it takes for that to reduce to 40 RPM, as well as to see how long it takes to come to rest. Okay, so now after reading the problem, there's a few things we want to point out. There's the givens. The mass of the flywheel is 350 kilograms. The mass of the engine is 120 kilograms. The radius gyration is 600 millimeters. The angular velocity at time 1 is 100 RPM. And the radius of the flywheel is equal to 225 millimeters. From that, we can assume that I is equal to mk, which we calculate out and get 120 kilograms per meter squared. And we can also find the angular velocity at time 1 and time 2. We do that by multiplying the RPM times 2 pi divided by 60 for the 60 seconds in a minute. And that's our answers for those two, omega 1 and omega 2. Okay, so now that we have the givens and the assumptions, the next step to every problem is to figure out the equations we're going to use and the diagrams. So here are the normal equations for impulse and momentum. Now, the easiest way to start with the problem is drawing the diagrams. I've already started out. It's the system momentum 1 plus the system exterior impulse is equal to system momentum 2. Now I already started off by drawing what the diagram looks like for system momentum 1. Now can I have a volunteer to come up and draw system exterior impulse? Okay, Connor, go ahead.
Sure. All right.
I'm forgetting one thing. Yes. Very well done, Connor. Very well done. Fantastic. You can have a seat. Do I have any volunteers who want to draw system momentum 2? Yes, Tyler, come on up.
This one's easy. Omega 2.
Very well done. Okay, class, so now that we've drawn the diagrams, the next thing to do is create the equation. So the equation we want to do is we want to take the moments about A. So we take the moment created by the flywheel, plus the moment created by the engine, minus the weight from the engine, is equal to the moment of the engine and the flywheel combined at the angular velocity times 2. Now we want to plug in the I is equal to the weight divided by G, otherwise known as M, times K squared. And we also want to plug in V is equal to RW. This gives us this equation right here. Okay, so now after that last equation, we want to solve for t. So after simplifying and solving for t, this is the equation that we get. So now, can somebody tell me how many equations we have and how many unknowns we have? Yes, Tyler.
Well, we have one equation and one unknown.
What is that unknown?
T.
Perfect. Now when we plug in all our givens, we get t is equal to 3.13 seconds. That is the amount of time that it takes for the speed of the flywheel, the angular velocity of the flywheel, to go from 100 RPMs to 40 RPM. Okay, so now for part B, we basically are doing the same exact thing, except there's one difference. Now, can anybody tell me what that is? Yes, Connor?
Well, since we plugged it in for 40 RPM for the first time, wouldn't we change omega 2 to 0 because it's coming to rest?
Exactly. So when we turn this value into 0, we plug in the same exact numbers, and we come out with t is equal to 5.22 seconds for the flywheel to come to rest. Okay, guys, so that's all I have for you for today. Since this is our last class, that's basically it, and I just want to wish you guys good luck on your finals.